Hi everyone, today our topic is adding and subtracting algebraic fractions. So it sounds really scary, but it's pretty much just going to follow the same rules as adding and subtracting regular fractions. So let's just do a quick review of what that was like. If you have, for example, 3/4 minus 1/3, you'll probably remember that you need to get common denominators in this situation because you have denominators that are not the same. So we are basically comparing parts that are not equal in size. Our denominators tell us how big our fractions are going to be, and we cannot add or subtract them if they are unequal in size. So in order to do that, we need to find the least common multiple. Let's take a look at this example and do that together. 3/4 minus 1/3. I need to find the common denominator between 4 and 3, or common multiple between 4 and 3. So 4 and 3 both can multiply to get to 12. So our LCM, or least common multiple, is 12. So we know we're going to get to the common denominator of 12. 4 will need to multiply by 3, so therefore the numerator needs to multiply by 3 as well, so that we keep it balanced. If we just multiply the denominator by 3, then we end up just tripling the size of the denominator and not the numerator, and we actually change the quantity from 3/4 to now 3/12. So we want to make sure that we are creating equivalent fractions. For 1/3, we are going to multiply top and bottom by 4. So at the end, we will end up with 9/12 minus 4/12. And then we know that that's the same as 9 minus 4 for our numerator over 12. So at the end, we get the answer of 5/12. Okay, so that's how we would add or subtract regular fractions with no variables or anything like that. So like I said, when we are adding and subtracting algebraic fractions, they follow the same rule. We just need to find the least common multiple so that we get common denominators, and then we can perform whatever operation it is, adding or subtracting. All right, so let's take a look at our first example from the book. This is example 5. They want you to express each of the following as a single fraction in its simplest form. So for A, we have 7 over 8n plus 1 over n squared. For B, we have x over 3y minus y over 4x. You'll notice that they do not have common denominators. So that's what we need to get them to. So we'll take a look at A first. For A, I have a denominator of 8n in one fraction, and I have n squared in the other. So I need to find, for A, my least common multiple. So what can they multiply to get to, both of these denominators? Well, I'm working with 8n and n squared. So in order to get them to the same multiple, the least common multiple, I'll need to take a look at what they each have, right? So for the first fraction's denominator, I have 8 times n. And for the second one, I have n times n, essentially, right? Because it is n squared. So I know they both have n in common, but my first denominator is missing an extra n, right? And my second denominator is missing that 8. So together, they could both get to 8n squared. So let's write down what that would look like if we were trying to get them to the same denominator. So 8n is missing an extra n. I'm going to multiply that by top and bottom. And then n squared is missing an 8. So after I multiply them together, I get 7n over 8n squared plus 8 over 8n squared as well. So I'm basically just seeing what they have in common and what they are lacking to get to their least common multiple. Okay, so then at the end, I am going to add our numerators together and keep our common denominator just like the previous problem that we did with regular fractions. So the common denominator stays the same, and then I'm basically just performing the operation using the numerators. And this would be my final answer here. There's nothing I can reduce. The numerator and denominator don't share anything in common. So this now is my final answer. I can't combine 7n and 8 because these two are not like terms. So this is the most I can do. It is in its simplest form. 7n plus 8 over 8n squared. Why don't you go ahead and pause the video and try 5b by yourself using that same procedure that we did here. Okay, let's look at b together. So I have x over 3y minus y over 4x. You know, they don't really have anything in common. So I can just multiply both by each other. So 3y is multiplied by 4x, and 4x is multiplied by 3y. So at the end, on the top, I get 4x squared over 4 times 3 is 12xy for my first fraction. And my second fraction would become 3y squared over also 12xy. We wanted them to get to the common denominator. We're going to keep that denominator on the bottom without doing anything. We're only going to perform our subtraction, which is the operation in this problem, to our numerator. So at the end, we get 4x squared minus 3y squared over 12xy as our final answer. There's nothing else we could do. We can't take out a common factor or anything like that. So that's it. That's all we can do here. That's our final answer. All right, let's move on to the next example. Example 6. Express each of the following as a single fraction in its simplest form. So same directions as before, but if you notice now, the denominators are now not just one single algebraic term, but they have two terms in there. So that should remind you of our work with binomials before, yeah? So let's do that first example together for A. When you have binomials, you'll notice that you can't really factor it in the same way that we did before, right? Because they're not related to each other through multiplication. There's addition or subtraction there. So, like I said, you're going to have to reach back in your brain and think about what you did when you had the product of binomials. This is a subtraction. What you can do essentially is just multiply them to each other. So x plus 2 would be multiplied by 7x minus 3. This will also be multiplied by 7x minus 3. This second fraction will be multiplied by x plus 2. Remember, top and bottom. Okay, so x plus 2 is multiplied top and bottom to the other fraction. 7x minus 3 is multiplied top and bottom to the first fraction. So at the end, you would get 4 times 7x minus 3 plus 5 times x plus 2. I'm just basically squishing them together to make one numerator. And then the bottom we're going to keep as x plus 2 times 7x minus 3. I actually don't want to multiply these together because after I simplify my numerator, I might be able to reduce or something and cancel stuff out. But we don't know yet. Let's go ahead and do our distribution, perform our distribution there. So we have 4 times 7x is 28x minus 12 plus 5x now plus 10. So that's after I distributed all my terms on my numerator. Okay, so this is what I get. I can simplify. I can combine my like terms. 28x plus 5x would be 33x. And then negative 12 plus 10 is minus 2. So, and then again, I'm going to keep my denominator like that. So I end up with 33x minus 2 over x plus 2 times 7x minus 3. I'm going to keep it like that. I don't want to actually multiply my binomials together because who knows, maybe later on I'm going to have to add or subtract to another fraction, algebraic fraction, or I need to multiply. So we're going to keep it like that in case this is actually part 1 of some greater problem. Okay, and that right now would be your final answer. Go ahead and try B on your own. 1 over x squared minus 25 plus 2 over 5 minus x. And then this denominator here for the first fraction is screaming special case, special situation here. So you might want to factor that first before you do anything. Okay, so let's actually do that. This x squared minus 25, you should know from previous lessons that that's actually going to be factored as x plus 5 times x minus 5, right? Because they are both perfect squares, and then there's no middle term, so we know a plus and minus will cancel out that middle term. So really we're looking at 1 over x plus 5 times x minus 5. And then you're probably thinking to yourself, well, why did you tell me to do that? Because that doesn't match with the denominator here. It's 5 minus x, not x minus 5. It's really close. Yes, it is very close. So let's use that to our advantage. X minus 5 is basically the same as if I were to take negative 1 and multiply by 5 minus x. Because if I were to do that, I would get negative 5. Negative times negative is positive, plus x, right? So this is really the same as x minus 5 if we were to switch these guys around. Okay, so it is basically the same except I have to multiply by negative 1. So let's actually rewrite this then, because we did a lot of work on this. So this is really 1 over x plus 5 times x minus 5, because we factored that out. And like we said, this 5 minus x is basically the same as multiplying by a negative 1. So let's just change this sign of this entire fractional algebraic fraction right here to a subtraction. So it's like we multiply this entire fraction by a negative 1, which is what we needed to flip this 5 minus x into an x minus 5. So if I want to change the signs, I got to change it to a negative here. Okay, that's going to help me change it. So now I have a problem that I actually can work with. Let me erase this so I have extra room. Okay, so now you'll probably notice that you have an x minus 5 here and an x minus 5 here. So really, I just have to multiply this x minus 5 by an x plus 5, in order for it to have the same common denominator. So make sure we do that to the top as well. Okay, so then now I get 1 minus 2 times x plus 5 over, now they will both have the same common denominator, which is x plus 5 times x minus 5, because that's what this one was lacking, the x plus 5, which we fixed. Now, you probably are going to be like, ooh, I can now cancel these two x plus 5s out. No, you cannot, because there's a subtraction here. And remember, we can only cancel them out if they're just related through multiplication. Okay, so resist that urge. What I can do is perform this distribution. So I end up with 1 minus 2x. Negative 2 times 5 is negative 10, minus 10. Okay. And then this 1 minus 10 can be simplified. So I end up with negative 2x, because that negative belongs to the 2x. And then 1 minus 10 is negative 9. So I end up with negative 2x minus 9 over x plus 5 times x minus 5. And remember, we want to keep it like that in case we do have to do some work later on. So this ends up being our final answer. Negative 2x minus 9 over x plus 5 times x minus 5. Nothing I can cancel out here. Okay, so remember, if they're related through these terms have addition or subtraction, you can't actually cancel that out, because you do have to perform that addition first. Order of operations still applies. Okay, let's do one last example. Example 7 from your book. Simplify 6 over x squared plus 14x plus 49 minus 11 over x plus 7 to a single fraction in its simplest form. Your first step, I would hope, is that you would factor this denominator here. And you can probably see that it might share a factor with x plus 7. So try x plus 7 as a factor. So go ahead and pause the video, try that on your own. Okay, so remember, we're going to factor x squared plus 14x plus 49 first. That would become x plus 7, actually, times x plus 7, or x plus 7 squared. Because 7 times 7 will get me that 49, and then I'll end up with 7x plus 7x, which will give me that 14x. Okay, so if I were to rewrite this problem now, I end up with x plus 7 times x plus 7 on the bottom, minus 11 over x plus 7. So then you'll see that the second fraction is missing an x plus 7. So I can then multiply top and bottom by an x plus 7 so that we end up with the same denominator of x plus 7 times x plus 7, or x plus 7 squared. I'm going to keep it like that in case I, in the future need to work on anything there. That negative 11 needs to be distributed. So this becomes 6 minus 11x. This is a negative 11 in the front. So negative 11 times 7 is negative 77. And then I can simplify by combining my 6 minus 77. So the negative 11 stays together. And this becomes minus 71, because 6 minus 77 is negative 71 over x plus 7 times x plus 7. And that's your final answer. And if I wanted to just make it a little prettier, I actually could rewrite that denominator as x plus 7 squared, but I'm not actually going to multiply it out. Okay, so I will actually make this my final answer.